Welcome back. As we get started with the first component of molecular forces, which is dipole-dipole interaction, first I want to define what a dipole means. Okay, a dipole is nothing but a pair of equal and opposite charge. Okay, it could be in a molecule, right? Say in a molecule. Okay, now how do we know something has a dipole or not? Or how do we know which of the two in a molecule, like say you have two elements in a molecule, how do we know which one gets the positive charge, which one gets the negative charge? And this is not entirely new to you, many of you, because we have learned the concept of electronegativity, and I had you develop positive and negative charges when we learned the concept of using electronegativity differences to determine the characteristic of a particular molecule. Right? So let's say I give you HCl and say HBr. Okay, these are two molecules. Okay, now dipole-dipole is pretty much only seen in compounds that are either polar or ionic. Okay, dipole-dipole is usually not seen in molecules that are non-polar because they have both negative or both positive charges, and that's usually not the case, right? So here we have HCl, and the value for hydrogen is 2.1, and the value for chlorine is 3.0, right? So it's, if you subtract 3.0 minus 2.1, you get 0.9, right? So if the value is above, say, 0.6 then or 0.5, then we say the molecule is polar, but it must be a little over 1.8 for it to be ionic, right? So this molecule is polar, right? Let's do the same for our HBr. So 2.1 is hydrogen, and then Br is 2.8, right? So it's 0.7, right? Which means it's still past that 0.6, so it's technically polar, right? So this right here is the dipole moment, the difference in electronegativity value, which is the dipole moment. So the dipole moment is usually indicated by the letter D. So D equals 0.9 for HCl, D equals 0.7 for HBr. Okay, so how do we assign charges? Well, between these two, this is the smallest, this is the largest. Whichever value is the largest of the two gets the partial negative charge. Keep in mind, an ionic compound also exhibits dipole-dipole, but the only difference is an ionic compound would have a full positive, full negative charge, whereas polar compounds have partial positive charge and partial negative charge. So the smallest of the two value gets the positive charge, the largest of the two gets the partial negative charge. Now, keep in mind, a positive charge written this way is not same as a positive charge written this way. Okay, this is partial positive charge, this is a full positive charge. Okay, this type of full positive or full negative, so let me write that as well for negative, not same as writing this. Okay, the full positive or full negative is usually reserved for compounds that are ionic. Partial positive and partial negative are usually reserved for compounds that are polar. Neither of these can be found in a compound that's purely nonpolar in nature, right? So similarly for HBr, delta is positive for hydrogen and delta is negative for bromine. Now, what's the larger implication of this is, let me write it within codes. The larger the dipole moment, Okay, the larger the dipole moment, the higher the boiling point of that substance in water. The higher the boiling point of that substance in water. Okay, what does that mean? Means if I put, say, this plus water and this also plus water and boil, this would have a higher boiling point. So HCl would have a higher boiling point than HBr, simply because of the fact that HCl has a higher dipole moment of D equals 0.9, whereas D is 0.7 for HBr. So this is partial positive and partial negative. So this partial positive and partial negative is what is usually referred to as a dipole. As I've written here, a pair of equal and opposite charge in a molecule, right? They're equal, 1 plus, 1 minus, and then opposite charge, yeah, they're plus and minus. So if you have this combination, this is usually referred to as a dipole. And one way you can get the dipole moment is through the electronegativity table. All right, I'm going to stop this video here. So the take-home message here is, the larger the dipole moment, the higher the boiling point of that substance in a universal solvent such as water. All right, when I come back, I'm going to talk to you about hydrogen bonding, which is very, very important. Hopefully, knowing the property of hydrogen bonding would help you answer a couple of questions that I posted up front in the major questions. All right, so stay tuned.